Hello and welcome to our today's video. In our today's video, we're going to handle the solutions of systems of linear equations. But now we are not going with the direct methods like the Crammers. We're going with the iterative methods. We have two iterative methods. One is the Gauss Jacobi Iterative method, and the other one is the Gauss-Seidel Iterative method, which is an improvement of the Gauss Jacobi. For today, we are starting with the Gauss Jacobi. Stick with us through all the videos so that you can learn more. Thank you for your support. Please like, share, and subscribe. Straight away, you're going first to derive the formula for the Gauss Jacobi. You are given a system of linear equations, and that system looks like this, which we have the coefficients are the a11, a12, a13, x, y, z is equals to b1. This is our equation 1. Next we have a21 of x plus a22 of y plus a33 of z is equals to b2. We are going to call it our equation 2. And lastly we have a31 of x plus a32 of y plus a33, this one is a23, sorry about that, of z is equals to b3. This is our equation 3. And we can comfortably write this as a matrix. That is, if we want to, we can have a11, a21, a31. Then we will have a12, a22, a32. We have a13, a23, a33. This will be equals to x, y, z is equals to b1, b2, b3. You can see it still takes the form of ax is equals to b. Now for the Gauss Jacobi iterative scheme, you can see we have system, we have 1, 2, 3, equation 1, 2, 3, equation 1, 2, and 3. In equation 1, we make x the subject. In equation 2, we make y the subject. And in equation 3, we make z the subject. And that's how we will get the Jacobi iterative scheme. Now let's just write it here. Sorry, we have in equation 1, we are making x the subject. So we will have 1 over a11 into b1 minus a12y minus a13z. We have said in equation 2 we are making y the subject. We are going to have a over a22 into, let's just use the curly brackets, into b2 minus a21 x minus a23 z. And then in the last equation, I'm making z the subject. We're going to have a over 1 over a33 into b3 minus a31 x minus a32y. In this, we are still making x the subject. But now remember that it's an iterative scheme, meaning it is something that is going to repeat itself. Now for us to get the iterative scheme, we have to introduce the n, xn. Let's just introduce the xn here, and you see. Now for x, our iterative scheme, we will have x n plus 1 is equals to a over a11 into b1 minus a12 yn minus a13 zn. For our y, it means that if we want to get yn plus 1, we will have 1 over a22 into b2 minus a21 xn minus a23 zn. And now for our zn, if you want to get zn plus 1, we will have 1 over a33 into b3 minus a31 xn minus a32 yn. That's our Jacobi iterative scheme. That enables us to get the xn plus 1, yn plus 1, zn plus 1. So these three equations, we have equation 1, equation 2, equation 3, give us the Jacobi iterative scheme. And now, as usual, we are going to have our starting point. Sorry about that. Our starting point, we have x naught, y naught, z naught, which is always given, and in case you're not given, we assume it to be 0, 0, 0. We're going to have a simple example. We are given 4x minus y plus z is equals to 7. We are given 4x minus 8y plus z is equals to minus 21. And then you have 2x plus y plus 5z is equals to 15. Let's take a short break. Kindly stay back so that you can come back and continue solving the problem. In the meantime, share, like, and subscribe, and thank you for your support. Bye for now.